Hello, I'm Will Thomas, the Spencer Weir Director of Research in History, Policy, and Culture at the American Institute of Physics. Welcome to this Lyne, Starling, Trimble lecture with Dr. Anne Lawrence Mathers, titled, What was Astrometeorology, and Why Does it Matter? There are a few things to be aware of before we begin, as shown on the screen. First, all attendees will be in listen-only mode throughout the lecture. To submit questions for the speaker, please use the Q&A function. If you are having technical difficulties, then use the chat feature. Finally, closed captions are available for this lecture. To turn them on, click the CC icon at the bottom of your Zoom window. Next, let me introduce our speaker, Dr. Anne Lawrence Mathers. Anne is a professor of medieval history at the University of Reading in the UK. She is a Fellow of the Royal Historical Society and of the Society of Antiquaries, and served on the Peer Review College of the UK's Arts and Humanities Research Council. She is the author of Medieval Meteorology, From Aristotle to the Almanac, which was based on research conducted while holding a Research Leaders Fellowship funded by the Arts and Humanities Research Council. Anne is also the author of The True History of Merlin the Magician, which explored the importance of Merlin's roles as a political prophet and reader of the skies. She has written various articles on medieval computus and calendar science, as well as on meteorology, and is a contributor to the Expanding Universe research project funded by the AHRC. This is producing a series of volumes on the scientific works of the 13th-century polymath Robert Grosseteste, and Anne's particular interest is in the Astro-meteorological treatise attributed to him, the De Impressionibus Eris. Please join me in welcoming Dr. Lawrence Mathers.
Thank you for your interest in medieval meteorology, and I hope very much that you will find the ideas and the images that I hope to present to you interesting, and I look forward very much to the questions and answers at the end. Here is my title, and I hope not only to present to you what astrometeorology was and the fact that it thrived and grew in complexity and acceptance, really, from the 9th century in the Islamic world and the 12th century in the medieval European Latin world up until the 17th century. Now, the term astrometeorology itself was coined in the 17th century by a supporter of the theories and methods which it included. However, historians have taken it up and started to use it more broadly for any system of weather forecasting in particular, which relied on observation of the planets and sometimes their relationship to the stars and how those linked to coming weather. Now, that has meant that the term astrometeorology is applied to the classical period, at least by some historians. My own view, for what it's worth, is that actual astrometeorology included detailed and quite precise weather forecasts calibrated for particular dates and locations, and that it was a rather different matter from what is described as astrometeorology in the classical period. Now, this slide about the star grouping, the Pleiades, and how they were important in classical meteorology helps, I hope, to make the point about what was distinctively classical. And this is that we have a number of texts from across the late classical period linking the calendar, whichever particular state calendar was in operation, to the time periods in the solar year when particular star groupings became visible and ceased to be visible close to the observer's horizon at the start or end of a period of daylight. And the texts record that the first appearance or last appearance of such groups, and the Pleiades were particularly regarded as significant for this, correlate with expected periods of sunny weather, windy weather, whatever it might be, and are times when certain agricultural activities in particular, sometimes maritime activities as well, should be undertaken. Now, how is that different then from what I would regard as a more medieval astrometeorology? Well, the crucial figure in the transition was Ptolemy, the noted astronomer, astrologer, and mapmaker of Alexandria in the 2nd century CE. You can see in this slide an image of him used as an introduction to a copy of one of his works produced in Paris early in the 13th century. The image shows him as a king or ruler, partly because of the medieval belief that he was to be identified as one of the Ptolemies who ruled Hellenistic Egypt, which was a mistake, but also in recognition of the fundamental importance given in medieval Latin Europe in the High Middle Ages to Ptolemy as an astronomer and astrologer. Now, Ptolemy's Almagest was translated in the 12th century, although not quite so frequently as his astrological work, the Tetrabiblos or Quadripartitum. And it was the Tetrabiblos which preserved and expounded Ptolemy's theories for the practical applications of his astronomical observations and data. The empirical data was fundamental, and Ptolemy worked hard to model planetary orbits to provide the mathematical modeling which underlay his version of planetary orbits. But the Tetrabiblos argues that what is still more noble for a natural philosopher, the medieval term for what we would call a scientist, was to put such data to practical and useful application. And something which recurs several times and to which he gives detailed attention in his Tetrabiblos is the possibility of making astrological weather forecasts, what I'm calling astrometeorology in the full sense, based on his astronomical data. And he provides methods of increasing detail and sophistication for doing that, based first of all on the fundamental natures and characteristics of each of the 7 planets in the system that prevailed at the time and throughout the medieval period, then paying particular attention to the phases of the moon and the times at which the moon and the sun were in significant relationships to one another. So new moons taken as the start of new lunar months and full moons. What was then important was to look at where the other planets were at the times of new and full moons, and to look at how these planetary bodies would be influencing one another based on their individual natures, their impact on earthly phenomena below. Now, if you wanted a more precise weather forecast, which of course Ptolemy assumes that many of his readers and users will, then you also had to pay attention to the matter of zodiac signs, the 30-degree sections of the ecliptic, directly linked in Ptolemy's time to constellations and star groupings, because the theory which Ptolemy accepted and propounded was that the power with which each planet actually exerted its qualities and its characteristics would be affected as it passed through various zodiac signs. Certain signs were regarded as the mansions or houses or elevations of planets, and equally others, usually the sign exactly opposite the house in which the planet was strong, would be the detriment or fall. In other words, the position in which that planet was weakened. So if you want to do a proper estimation of how each planet will affect the qualities of the sublunar air or atmosphere and what that might do to the weather, then that also has to be taken into account. Of course, Ptolemy takes it almost for granted that another underlying part of this process of making a weather forecast will be that the forecaster will pay attention to the particular location and its position on the Earth's spherical surface and the climate which dominated in that location, in that climatic zone, according to classical Greek meteorology, for the time of year concerned. There's no assumption that because the planets are so superior and so powerful, their effects will be precisely the same for a given interrelationship of planets, regardless of the season down on Earth. So this is already a very sophisticated method capable of producing monthly, weekly, or even daily weather forecasts for individual locations within the known surface of the Earth. Now, to come backwards a little bit, before the 12th century, that level of sophistication in meteorology and weather forecasting and the sophistication in astronomy, which it depended on, do not seem to have been available in Western Europe. What you're looking at is an image produced in the Carolingian Empire in the 9th century, pulling together a very classical looking set of images to produce a diagram, an artistic diagram, of calculated rough locations of planets for Easter in a chosen year early in the 9th century. Now, that paid some attention to the scholarly works of Isidore of Seville in the 7th century and the English Benedictine monk Bede, who wrote a fundamental textbook on the monastic science known as Computus, which linked simple astronomical calculations to the church calendar for each year. But none of this included detailed knowledge of planetary orbits, let alone the capacity to calculate planetary positions day by day. And another example of that is shown in this Anglo-Saxon copy of a Carolingian version of a Roman astronomical poem. The poem was written by Aratus, originally in Greek and known as the Phenomena. Various Latin translations were produced, and by the 9th century, it was the basis for beautifully illustrated star catalogues and astronomical encyclopedias. This is the image of the constellation and zodiac sign Aries. You can just see that there is an attempt to give a sort of very schematic idea of where in the constellation individual stars are located in the form of those reddish gold blobs. But the text describing the stars and the features of Aries as a constellation and as a zodiac sign has been artistically fitted into the figure of Aries the ram and provides very little practically useful astronomical data. It was in the Arab Empire and the Islamic world that Ptolemy's work on astronomy more generally and astro-meteorological weather forecasting in particular was taken up and built on. Rulers and scientists in the empire, particularly in the 9th century and from then on, invested major resources in astronomical equipment and observations. They updated Ptolemy's work on star cataloguing and observing of both stellar and planetary positions. They came up with even more mathematically sophisticated models to explain and deal with phenomena like the precession of the equinoxes. And almost all of the major Islamic writers, most of them working in Arabic, some of them in Hebrew, produced wide-ranging textbooks on what we would call astrology, sometimes in Latin translation in the medieval period, also called astronomy, within which weather forecasting played a very prominent part. The astronomer and natural philosopher Masha Allah, known in medieval Latin Europe as Messahala, wrote a significant treatise on winds and rains as part of his major astrological encyclopedia. Al-Kindi, also famous as a natural philosopher and mathematician, as well as astronomer and astrologer, produced an overall encyclopedia of astronomy and astrology, which wasn't translated into Latin until the 13th century. But the demand for works on meteorology and weather forecasting in particular in Latin Europe was such that 12th century Latin translations of extracts and short treatises, or so-called letters by Al-Kindi, began to circulate separately, and sometimes were rather fraudulently presented by translators as their own work, presumably because those translators were very aware of the level of demand for up-to-date, almost scholarly, fashionable versions of producing weather forecasts. The usual Latin term for these works, like other astro-meteorological treatises, was something like De Mutatione Temporum, or On the Change of Times, which here would translate as weather. Others make reference to changes in the air or atmosphere, since it was a fundamental part of the model that it's changes in the balance of the elements of air, fire, and water in the atmosphere between the Earth and the Moon that drive changes in the weather. Apologies for that delay. What I'm calling the new technology consists of the versions of that Islamic work which were taken up and reproduced in medieval Latin Europe. So as well as Latin translations of natural, philosophical and astrometeorological works by Islamic scholars, you get enthusiastic adoption of the astrolabe from the late 11th century, but more particularly the 12th century onwards, as a tool which enabled precise calculation of the positions of major stars, indicated by labelled pointers on the star map or route on the outer face of the astrolabe, in relation to a view of the heavens engraved into an underlying plate fitted into the central portion of the astrolabe, which was calibrated for a particular location. And most astrolabes by the later 12th century came equipped with a set of such plates, so that the user could switch plates depending on if they were traveling, where they had moved to. It also meant that one astrolabe could be sold or copied across medieval Europe. In the right-hand part of the slide, you've got a surviving set of actual horoscopes, probably produced in England towards the middle of the 12th century, and already showing the ability on the part of at least a handful of astronomer-astrologers to calculate the zodiac positions and house positions of each of the 7 planets in detail for a chosen day and location, and then to make specific forecasts based on those charts. Now, these do not, I have to confess, relate to weather forecasting. They relate to political and military events. But the basic way of presenting the astrological data would be the same for a weather forecast. And here, by the 13th century, we have some surviving, in the case of the printed example, obviously later, cases of developing astrometeorology. It was so established that by the 13th century, celebrity astrologers like Guido Bonatti, perhaps particularly, were issuing within their own encyclopedias of astrology and its methods and its applications, detailed commentaries on how astrometeorology was to be done, quite often going back to Al-Kindi. Ptolemy by now has been left behind. It's Al-Kindi who is quite often referred to as the original master of astrometeorology, but then updating it by providing their own preferred methods within the total range of equipment provided for the astrometeorologist. It's a bit like trust me, I'm a doctor, only in this case it's trust me, I'm an astrometeorologist. And the tables, the printed tables in the right-hand part of the image show you a later version of the types of tables which became fundamental for practicing astrologers from the 12th century onwards. They were updated, first of all, in Islamic Spain in the 11th century. Those were translated into Latin from the 12th century on. And then the famous tables of Toledo, updating for a location in Spain in the 13th century, provided the basis on which the scholarly astronomers and astrologers in universities like Paris in particular, and a little later Oxford in England, built, so that it was possible for someone who wanted to produce an astrometeorological weather forecast following, let's say, the method of Guido Bonatti, not to have to do detailed calculations of daily planetary positions from scratch, but to start by consulting a set of tables which would provide mean readings, which could be much more quickly and effectively updated if necessary for the more rapidly moving planets. However, that does not mean that there were no practical problems. The scholar and natural philosopher and theologian Robert Grosseteste, Bishop of Lincoln, who spent some time in Paris and is also linked to the rise of the University of Oxford, shows an interest in several of his works in astrology more generally and astrometeorology in particular. This is from a manuscript in the Bodleian Library in Oxford, manuscript Saville 21, and it shows a pair of annual horoscopes linked to what was known as the Aries ingress, or the day on which the sun moved into the sign of Aries, which was itself linked to the spring equinox. And planetary positions at this key moment in the solar year were taken as particularly important for those who wanted to make large-scale predictions of factors like coming weather, the likelihood of natural disasters, major illnesses, and so on. And what's interesting about this is we have what looks like Grosseteste's handwriting entering data into this basic astrological chart. And in a slightly later work, he commented on the difficulty of making really precise and accurate calculations of such phenomena for a particular location, and on that basis criticized astrologers who made what he regarded as fraudulent claims of accuracy. Elsewhere, like other medieval theologians, he also criticized the type of astrological predictions which contradicted the church's teachings on individual free will, But it's important to note that he does not reject the practical importance of astrometeorology. He just questions whether it's really possible to be as precise as some astrologers were claiming. Now, that is particularly interesting because a fairly popular medieval Latin treatise on astrometeorology was credited to Grosseteste himself, and this is from a surviving, relatively early copy of it in the British Library. What it proposed was that basic astrometeorology should be acquired by anyone who effectively has a social conscience. If you wish to provide, as the Bible itself taught, that rulers and leaders should, for coming periods of bad weather and consequent famines and diseases, then it's important to know how to make astrometeorological predictions. And the text attributed to Grosseteste, although not actually, it has to be said, within his own lifetime, provides a simplified version of how to do it, which is interestingly in line with his criticisms of the fraudulently accurate, in his view, claims made by some astrologers. Now, what he proposes is that using a simplified set of tables, the user should do a circular chart like the one shown in the slide here, with a circle for each of the planets. The Earth and the position of the observer is taken to be, if you like, in the center of the circle. And you've got the zodiac houses around the outside. So you simply put each planet into the zodiac sign on which it will be located. So you're not trying to be overly precise. The relationships within the 360 degrees of the circle between the zodiac signs are then important, as are the relative levels of strength, going all the way back to Ptolemy and what I said about that, attributed to each planet when it is in that particular zodiac sign. And Grosseteste, like other 13th century astronomers and astrologers, actually provides numerical values to be applied to the strength of each planet for each individual zodiac sign that it might be found in. So having placed your planets in the relevant zodiac signs, you then consult the table to see the numerical level of strength to be attributed to each planet, tot up the values as has been done in the sample given in this diagram, and then see which planets are going to prevail on your chosen day. And the text provides a sample weather forecast for a chosen day in 1249, and notes, in fact, that we are clearly later than that day and later than 1249, because notes that the forecast turned out to be correct, although it has to be said it wasn't terribly detailed. It was basically a prediction that on that day the sun would prevail. There might be some clouds, but it would basically be dry. So it's not terribly detailed, but enough for the user to be able to decide whether any natural disaster is likely to follow. The warning comes up a little later when the text warns that due to planetary conjunctions and their relationship to eclipses which are coming up, there is likely to be a long drawn out period lasting for several years of cold and drought, and it's important for provision to be made against that. So this shows the importance of astrometeorology, not just as a theoretical, purely book-based pursuit, but as something to be used by those who have responsibilities in society. That, I think, this perception of social usefulness is important when taking account of the fact that when the new technology of printing came along, what become known as the Almanacs, starting out as annual prognostications, were amongst the very first things to become popular forms of printing. Indeed, they were the mainstay, the economic mainstay of a lot of early European printers from the late 15th century on. And again, the technology of print was fundamental in making available new tools in the form of calendars and ephemerides issued by very highly regarded astrologers like Georg Peuerbach and his own follower Regiomontanus, the issuer and printer of the data that you see here for the month of January. These give you very thoroughly calculated planetary positions, which can be used for weather forecasting, amongst other things. But Regiomontanus and 17th century followers make it clear still that weather forecasting, because of its fundamental economic, political, and military applications, is a particular area of interest within all of this. And here we have a late 16th century almanac produced in England in 1589 for the year 1590. The producer is Buckminster, and this is his prediction for October 1590. And you'll see it links predictions of the positions of significant planets to brief but valuable daily weather forecasts for each day in that month. And that type of weather forecasting was fundamental for the almanacs right through into the 18th century. And it was linked, I think, and other historians have argued the same, to the growing practice of keeping weather diaries, which could be linked to the forecasts which would be produced by astro-meteorological calculations. This one is from a 13th century manuscript which has been identified as being in the handwriting of the Oxford scholar Roger Bacon. And as you will see, you have planetary data set out in tabular form in the main column of the text, and weather observations translated into English in the right-hand part of the slide for the same days, so that expert readers could compare the data for the planets with what actually happened in, we assume, Oxford on that day in the 13th century. And this idea of keeping diaries of weather observations, linking them to astrometeorological data, and yet still producing astrometeorological forecasts, goes on through the 17th century. No less a name than Johannes Kepler was a leading figure in this from 1593, and from 1617 his printed ephemerides include weather observations, while his calendars continue to offer weather predictions linked to the astronomical and astrological data. In places like England and state capitals across Germany as well, you have scholars taking up the advocated practice of keeping weather diaries. And yes, these may well be moving away from straightforward belief in astrological causation. But on the other hand, my concluding argument as to why astrometeorology was important, despite the fact that the theoretical model on which it was based was fundamentally flawed, fundamentally wrong, was that without it, this advocacy of keeping weather diaries and weather observations for a given location every day for periods of years would not have become established as a practice to be adopted by scholars across Europe, if not wider as well, and that modern meteorology therefore would have been at the very least deprived of a key resource, and perhaps might even have developed along very different lines, with which possibly challenging observation for any meteorologists in the audience, I will stop.
All right, I think that we are live now. You'll notice subtle differences in the lighting and in our clothing that suggest that we've moved away from the pre-recorded suggestion segment of the program to the live Q&A portion. So, Anne, thanks for an absolutely wonderful talk. I learned a lot. I'm myself a historian of the 20th century, a policy analyst of the 21st century, but I've always kind of tried to keep an eye on earlier periods to learn what the status of the scholarship is, and I thought that this was absolutely fascinating. So let me go to our first online question. If the astrometeorologists did not provide useful predictions, why were they followed? Were there powerful patrons supporting them for political reasons?
Basically, yes. And I mean, I would challenge that thing about the predictions not being useful. I mean, clearly they could not be scientifically accurate in the modern sense, but for people who believed that there was a sort of elemental link between the planets and matter down here on Earth, and that those links worked by changing what was going on in what we would think of as the Earth's atmosphere, thereby creating weather, these predictions were useful because as now, people wanted to know what the weather was going to be like. If you're a farmer, and of course, you know, farming, food production was the biggest economic activity in this society by far, you need to know, is it going to be a dry season? Is it going to be a wet season? Are your crops going to be at danger from flooding or drought or anything like that? And as in that 13th century example that I dwelt on in some detail, people, even theologians who challenged the precision that some astrologers were claiming, did believe that it was possible to get sort of macro forecasts in that level, and even that there was a kind of a social duty to do it, and that anyone who could handle the text and do the mathematical calculations, so we're basically talking university educated scholars, kind of had a duty to do it. And yes, powerful patrons would expect to have astrologists, including the skills of astrometeorology as well as astromedicine, on tap for them, and getting the services of someone who was believed to be particularly good at this kind of prediction was something they would pay for. If you look at the careers of the big name astrologers from Guido Bonatti in the 13th century right through the 14th and the 15th century, you see them moving around from one royal court or princely court or ducal court to another very quickly. And as university after university is founded across Western, Central and Eastern Europe in the 15th century, one of the early chairs founded in each of those universities is for astronomers and astrologers. And one of the big things they have to do while they're holding that chair is give an annual prediction or prognostication, including weather month by month. So people would pay for this, and it's kind of a combination of strategic advantage and social duty, I think.
All right, so you have one question about that's really attended for us here at AIP. Will the recording of this presentation be available for later viewing? And I believe that the answer to that is yes. It will not be immediately available, but we will be making it available via our YouTube site quite soon. So the next question for you, Anne, is thanks for a wonderful talk. This summer, I visited one of the oldest meteorological stations in Central Europe, the astronomical tower in the Clementium complex in Prague. They began climatic observations in 1775. Was the astrometeorological tradition still going on by the late 18th century?
Not in any serious academic circles. Printed almanacs were still being issued. in the US by then, as well as still across Europe. But people who were employed in observatories like the one in Prague would no longer have taken astrometeorology itself seriously. What I'm arguing, though, is that if it weren't for the legacy of astrometeorology, they wouldn't have had all of these weather records and weather diaries to call upon. And the idea that you made detailed recordings of weather, rainfall, snow, frost, wind directions, and so on, persisted long after any serious belief that these changes were caused by planetary movements and planetary interrelationships. So the data would still be there, even though I think the people in the observatory would not be using that as an explanatory model anymore. I hope that answers the question.
So for our next question, thank you for your talk. Is there evidence that the astrometeorological predictions were more accurate as they became more complex?
Sadly, no. I mean, I've had a try at this myself, and I hope that I set out the basics of it clearly. But as I also suggested, you start out with what sounds like a fairly simple system of 12 zodiac signs, 7 planets, and however many other significant stars and constellations you want to bring in. But once you introduce the factor of movement into it, that's where different astrologers and astronomers came up with different models of, for instance, Al-Kindi, way back in the 9th century, argues that this is not any kind of supernatural phenomenon. It's all about movement and what we would call friction and the heat produced by movement. And that as the planets move in their different speeds and as they come together and move apart, so you get differing patterns of heat being produced in the atmosphere. And he goes on to argue that this, for instance, triggers winds. He says, where the air is significantly cooled down, it will shrink. And therefore warmer air from other locations will expand into the cool locations, and then you will get stronger than average winds, and that will affect the weather. Similarly, the movements of the moon pull on water on the surface of Earth more as the moon comes closer. So it's not only about the phase of the moon, it's about the position of the moon. And that's why the interaction between the moon and other groupings of planets are so important. But of course, the sophistication is incredible, and the mathematics going into all of this. If you've had a look at Ptolemy's Almagest, the mathematics of it is way over my head. I mean, I was taught at school about sines, cosines, and tans, but it was a long time ago, and the headache finished some decades ago. But that kind of mathematical sophistication was brought to bear by the really top level university astrometeorologists. But sadly, sophistication and mathematical accuracy couldn't produce an accurate forecast because the model itself wasn't capable of producing one.
And I'll ask a question of my own, and you've just touched on it a bit. I was interested in the mechanics of this because you said that they paid very close attention to the effects of the stars on the air and the elements in general. But I'm wondering, and so it's evident that they did have very well-developed theories about heat and that sort of thing. What was the relationship, if any, between those theories and their theories about astromedicine or about the relationship between astrology and political events? Were there similar mechanistic, as we might say, explanations? And did those interrelate? Because we often think from the Enlightenment period about the relationship between climate and medicine. And did that extend all the way back into this tradition?
Oh, yeah. Because the medieval medicine, to take that one, was built very much on the classical model of the humours. And that had as a major component the idea that the humours in your body are affected by the climate, and within the climate zone that you're in, by the seasons. and hence all of those prescriptions about how to look after yourself, whether to keep warm, whether to eat warming foods, whether to drink cooling drinks, and so on. And already in the classical period, warm and cool do not simply relate to temperature as we would think of it. Certain foods are thought to have cooling properties, whether they're served to you hot or cold, if that makes any sense. And I was dwelling on the mechanistic side of it all. And by the medieval period, because of the sophistication with which planetary positions and interrelationships could be calculated, they had moved on to say, well, just as the planets and their positions affect the Earth's atmosphere and the elemental matter on Earth, so they affect the elemental matter in your body. And a dominant theory was that the matter of your body would receive a kind of imprint from the stars at the moment that you were born, because you're born in a very malleable, sort of soft condition. And so that kind of prints a certain set of material qualities into you, which is then dynamically acted upon by the planets as they move around. So just as the planets affect the weather in the location that you inhabit, so they interact with this celestial stamping in your health system. And so you need a good astrologer, if you can afford them, to advise you on how your particular personal planetary conjunction is going to be affected by the external planetary conjunctions. And no theologian would have a problem with that, because it's all about matter. Where it becomes problematic for theologians is if you start to say, I couldn't help murdering that person. Mars was absolutely powerful in relation to me on that particular day in that place, and I just couldn't help going berserk. And every theologian said, no, you have free will, you have a soul, you have rationality, and those things give you the power to override planetary influences. So it's a mechanistic system, but only within certain limits. But up until the late 17th century, you practically couldn't be a highly paid, highly skilled physician without also being an astrologer.
Wonderful. So we have from the audience a very specific question and a very general question. I'll go to the specific one first.
Right.
Did Hildegard of Bingen engage in this?
Yes and no. She, as far as I understand it, she had her own version, which is why I didn't discuss her in the book I wrote about all of this. She clearly knew the basics of the theory, I would say, but as she did with other things like producing what was effectively her own bestiary and her own medical textbook and so on, she kind of comes up with her own version of it based on what are effectively revelations. So she's not saying, I just made this all up. She's saying, this was revealed to me. So yes, but only up to a point and in her own very specific way. And I have to confess, I'm not an expert on her version.
All right, so our very general question is, do we see any aspect of this legacy persisting today in some other forms?
Ooh, well, there are, I mean, I don't think it's a legacy of this, but I was fascinated to see a paper published a few years ago, which had actually established that certain planetary conjunctions and movements do have very tiny effects on the Earth's atmosphere, although it happens over periods of thousands of years, not the tiny time periods that I'm talking about. On an entirely different level, you still get published almanacs with astrological readings about coming natural disasters, plagues, wars, and so on being produced. And I guess if you accept my argument that the keeping of weather records and correlating them with other data in order to produce models of what drives and affects weather in different regions in different seasons goes all the way back to these astrometeorologists, then that's still a legacy. Because I think something like that 13th century manuscript which seems to show the handwriting of Roger Bacon. And there's others across what we would think of as Germany in the 14th and 15th centuries and so on, show that what they're doing is trying to make their version of astrometeorology more locally accurate and identifying the factors in this whole complicated network of astrometeorological factors, the factors that are most important in their particular location and their particular modeling of the weather. So I suppose I would say, well, if you accept that argument, then the ongoing drive by meteorologists to produce ever more dynamic models of the leading factors driving weather is kind of not so much a legacy, but a sort of ongoing practice and tradition.
I'd hesitate to draw a straight line, but I think of things like the Milankovitch cycles and their connections to climate. And it's kind of an unexpected thing to come up with, but it's interesting to contemplate. So let's see here. Okay, so next question from the audience. Could you talk about how theoretical treatises on weather, like Aristotle's work, or polemical works on astrology, relate to astrometeorology and weather predictions?
Well, Aristotle's work didn't really relate directly to astrometeorology, partly because the Islamic age astronomers, well, from Ptolemy onwards, astronomers were kind of producing data which showed, although practically none of them come out and say it directly, that Aristotle's theoretical universe doesn't work. It is not possible to model the observed motions of the planets across the heavens on the assumption that they are all exactly concentric and all following precise circles. And yet Aristotle's views on perfection and the perfection of the circle and the sphere and so on would lead you to suggest that that ought to be the case. I mean, even some medieval theologians and natural philosophers have problems with the complexities that Ptolemy had to introduce, because he has to have not only epicycles, so that to explain the fact that the planets sometimes appear to be moving backwards, but he has to have equants and eccentrics as well. And you get quite subtle arguments amongst mathematicians and astronomers in the Middle Ages about whether these points are real or whether they're just mathematical abstractions. And if they're mathematical abstractions, what does that say about the motions of the planets? Because how can the motions of the planets be driven by mathematical abstractions? So again, it becomes a kind of scientific problem that various people try to produce answers to, but there's never a point at which they say, okay, we have done it, this solves all the problems. And I guess that's not so different from modern science either.
I'm struck by many of the parallels. Okay, so our next question is from Joanna Behrman, who is our organizer behind the scenes of this entire event, and who I would just like to acknowledge and thank for doing a tremendous job. So her question is about what kinds of weather phenomena were recorded. That is, were different kinds of clouds recorded, or only rain versus no rains? And were any of those quantitatively recorded? For example, how much it rained?
Yeah, the number of different types, at first, in the early versions, it's very much up to the individual observer what they record. And what they record is usually linked to what they want to be able to forecast in the future. So interestingly, an observer over in what to us is Eastern Germany is particularly interested in snow. He wants to know when it's going to snow. In England, nobody will be surprised to hear that the dominant phenomenon is rain. By the 16th century, you get some people starting to say, well, if these observations are going to work, then we all need to be recording the same kind of thing. So you get lists of what the diarists are asked to look out for. And then in the 17th century, you get the phenomenon of increasingly accurate technology tools for measuring rainfall. And in England, for instance, in London, you get the newly formed Royal Society having access to simple versions of barometers and thermometers and rainfall gauges. And these are solemnly put up on the roof of the Royal Society's building in London, so that they can not only say what they're measuring, but know that other people with the same instruments will be able to make comparable measurements. And so they correspond with one another and they can compare. And when people go traveling, they come back with data from the places that they visited. So it all gets more and more precise and capable, not only of being recorded, but of being compared across place and time.
All right. Well, we have a couple of general compliments in the Q&A box saying marvelous insights and thank you so much for the wonderful talk, with no question associated with them. But I just wanted to make sure that you know that our audience very much appreciates you. So I guess I will continue on with a couple of questions of my own. The first has to do with kind of the probabilities surrounding some of the predictions that were made. Did they use that as a way to explain, for example, if their predictions weren't quite right? Was there a sense that we think there's a strong likelihood, or it's really up in the air, we don't know what the weather's going to be? Does that sort of sensibility appear?
Certainly the idea that there is a strong likelihood comes up. And of course, it was always possible, as I guess it was possible for weather forecasters until quite recently, to say, well, look, the range of factors operating on the weather, particularly if you want a day-by-day forecast, is so great and so dynamic that it comes down to the individual's experience and judgment. I mean, anybody can predict that somewhere in the northern hemisphere in the month of January it will be cold and it will probably rain. So they could predict that with a high degree of certainty. But when it comes down to individual and daily forecasts, then what you start to see is, well, I made the mistake of doing a Grosseteste style forecast and it oversimplified, and I should have brought in this factor. There's a fantastic thing that I love called the opening of the doors, which has to do with which of the mansions of the moon is occupying and how wet that mansion is, and what other planets are moving towards and away from the moon. And so how do you balance one factor against another? And that's where that whole "trust me, I'm an astrometeorologist" thing comes in, because people like Bonatti start to say, well, I'm so good at this that apparently, according to one Italian chronicler in the 13th century, he even advised the ruler who was employing him at the time at what hour of the day he should send his armies into battle.
All right. Well, Anne, I could go on all day, but I'm told by Joanna that that probably had to be our last question. So
Okay.
I'd just like to thank you very much. It's been a great Q&A, and I myself am totally fascinated by this, and we've had good audience engagement. And so with that, I suppose I'll have to turn it back over to our pre-recorded selves to sign us off here. And I think that'll involve another expression of appreciation. But just live, thank you so much. It's been great.
Well, thank you for the invitation, and I've really enjoyed doing it and the Q&A as well, so thank you.
Thank you all again for coming to this Trimble lecture with Dr. Anne Lawrence Mathers. To watch other Trimble lectures, check out our YouTube channel, AIP History Programs. For updates on future Trimble lectures, you can follow us on Twitter or subscribe to our email list on our website. Our next lecture will be given by Dr. Bruce Hunt on November 15th at 3 p.m. Eastern Time. His lecture is entitled "The Victorian Cable Empire and the Making of Maxwell's Equations." We hope that you'll join us then.